Okay, this is Mr. Wyrick. I'm here to take you through this review for today. I'll keep an eye on the clock, make sure that we still get you out of here on time. Square root of 24 on this first one if we're simplifying. You can do birthday cake method on this. I just look for the largest perfect square. This is going to split into 4 and 6. The square root of 4 is 2, so that's 2 square root of 6. On number 2 is 75, that's 25 and 3. Square root of 25 is 5, that's 5 square root of 3. Now we have talked about this before. You can't use the calculator to get you the right answer, but you can check your answer. On this one, the square root of 3 is 1 point blah blah blah. You multiply that by 5, you should probably have like 6 and some change, maybe 7 and some change. And if you type in the square root of 75, you should actually get that exact same thing. Okay, so that's what you kind of have to be on the lookout for. Check your answer to make sure it's the right one. You can use the calculator on that, but there are 26 questions, so you can't waste a ton of time doing that on every single one. The cube root of 16, again, you can do the birthday cake. I'll do it on this one. We got 16, that's 2 and 8, that's 2 and 4, that's 2 and 2, which is 2 and 1. Got my candle on top of the cake, I know I'm done. This has an index of 3, so I'm looking for groups of 3. I have 1, 2, 3 2s. That's a 2 on the outside. I have a 2 left underneath. The index stays the same. Make sure you still have that index of 3. On this one, the fourth root of 48, I know a fourth root, it's 16, and 16 times 3 makes 48. Square root of 16 is 4, square root of that is 2. There was a negative on the outside, it'll be negative, and then that'd be fourth root of the 3 that we have left underneath. Okay? On this one, when we start getting the variables in there, you take the exponent and divide it by the index. The 50 breaks down basically like it does before, 25 and 2. Square root of that's 5. We have a 4 on the outside. 5 times 4 is 20. 5 is divided by 2. It goes in there twice evenly. That's x squared. That's 4 of my x's. So I still have an x left underneath, and I still have this 2 left underneath. On this one with the fourth, I've been working this one with people already. So this is 6 2s. One group of 4 puts 1 2 on the outside. The 2 4s, or the 2 2s left underneath will give you fourth root of 4. A to the fourth, and the fourth root of that is just A. B to the fourth, and the fourth root of that is just B. On this one, the cube root of negative 8 is negative 2. The cube root of d squared stays the cube root of d squared. The cube root of f to the fifth, you get a single f on the outside, and you have f squared left on the inside. All right? On number 8, the r squared and the t go on the top. And you can't reduce anything here, so you're just taking the square root of the top. The square root of 25 is 5. Square root of r squared is r. The square root of t stays the square root of t. On the bottom, the square root of 36 is 6. On number 9, we can't reduce this. We have a negative square root of 3 over square root of 7. We multiply by square root of 7 over square root of 7. Not really a conjugate, just making it to where we don't have a radical left on the bottom. This is going to be the negative square root of 21 over 7. That's where we stop. On this one with the cube root, again, we can't reduce 2 over 9. So this is the cube root of 2 over the cube root of 9. I could multiply by the cube root of 9 squared to end up with 9 on the bottom, but that's not actually the smallest thing I can come out of on this one, because I could split 9 into 3 and 3. If I had one more 3, that would be a group of 3, and I could move that to the outside. So that's what I'm going to end up doing, is multiplying by the cube root of 3 over the cube root of 3. That gives me the cube root of 6 over 3. Okay? Be careful when it's cubed roots. Those would be the ones that I would definitely be kind of using the calculator to check my work, see if what I came up with was correct, and that I've got it reduced properly. All right? On this one, again, we have the g would reduce, so we have g square root of 2g over the square root of 5z. We have to multiply by the square root of 5z, top and bottom. So we have 5z on the bottom. On the top, outside by outside, inside by inside, the g stays where it is. 2 times 5 is 10. That doesn't reduce still. And then we have a g and a z. On number 12, outside by outside, inside by inside, that's 15 times the square root of 9. The square root of 9 is 3, so that's 45. Okay, that would be one that the calculator would give you a right answer. On this one, you can either multiply and then reduce, or you can reduce and multiply. It won't make a difference. But if you reduce and multiply, you're probably going to have to reduce again after that. So I usually don't bother. This is 12 square root of 240. 240 would be divisible by 8. That'd be 8 and 30. And then 8 times 8 would be 16. So you can get a 16 out of this. It'd be 16 and 15 when you split it up. Square root of 16 is 4. So that multiplied by the outside would give me 48 square root of 15. On this one, number 14, we got to reduce. 8 is 2 square root of 2. 50 is 25, or not 25. 5 square root of 2. The square root of 25, which is 5. Square root of 2, this would be 1. So 1, 2, 3, plus 5 is 8. That would be 8 square root of 2. Okay. On this one, 12 is 2 square root of 3, and then minus 2 square root of 3. The 108 is 36 and 3. Square root of 36 is 6, so that'd be 6 square root of 3, which 2 square root of 3 minus 2 square root of 3 is nothing. So the answer is 6 square root of 3. On this one, this would be 9 and 5, so that'd be 3 square root of 5. The 80 is going to be 16 and 5, which is 4 square root of 5. 8 minus 3 would be 5, minus 4 would be 1, so that's 1 square root of 5, or just the square root of 5. Negative? No. That's positive. Trying to throw me off my game here. 48 would be 16 and 3, so that's 4 square root of 3 times 2 would be 8 square root of 3. 75 is going to be 25 and 3, so that's 5 square root of 3. And then 12 is 4 and 3, which is 2 square root of 3. So this is exactly the same as that last problem, pretty much. 8 minus 5 would be 3, minus 2 would be 1, which is just the square root of 3. On number 18, this one is the boxes. 2 square root of 3, 6 minus the square root of 2, that's 12. That's 6 square root of 3, that's minus 2 square root of 2, and this is minus the square root of 6. I apologize, that's really small. But none of those are like terms. You can't put them together. It's 12 plus 6 square root of 3 minus 2 square root of 2 minus the square root of 6. Nothing you can do to reduce any part of that, to connect any part of that. It's going to stay separate. Okay? This one, on number 19, those are conjugates. It's the minus and the plus. 1 squared is 1. Square root of 5 squared is 5. So that's 1 minus 5, which is negative 4. On this one, it's going to end up the same as the one above it. 3 times 5 is going to give me 15. 5 times the negative square root of 7 is minus 5, square root of 7. 3 times square root of 2 is plus 3, square root of 2. And then square root of 7 and square root of 2 means it's minus the square root of 14. Nothing I can do there. There's no like terms. I can't reduce anything. It's not going to work. On this last one, square root of 2, when it's squared, you're multiplying it by itself. So if you need to write it again to remember that, you don't square the individual parts. You multiply it by itself. Square root of 2 times square root of 2 is 2. Square root of 2 times square root of 6 is the square root of 12, which is a minus 2 square root of 3. We have 2 of those. Square root of 6 times square root of 6, they're both negative. It's going to give me a positive 6. 2 and 6 is going to make 8. Negative 2 square root of 3 and negative 2 square root of 3 is going to make minus 4 square root of 3. If there's anything else on here that you need to see slowed down, gone over again, whatever, make sure to stop by tutorials after school, before school, whatever, and get that fixed.